experiment is design and implement a mod n synchronous up counter using JK flip-flop ICs and demonstrate its working. Okay, so we need to use JK flip-flop to design and also to implement the synchronous up counter. Okay, so this is the JK flip-flops, that is IC number 7476. Here I am demonstrating this experiment for mod 5 synchronous up counter. For mod 5 synchronous up counter, we need 3 JK flip-flops. As we have discussed in the previous video, to design mod 5 synchronous up counter, we need 3 JK flip-flop. In a single IC, we will be having 2 JK flip-flops like this. So the flip-flop 1 and flip-flop 2 will comes under IC1 and flip-flop 3 will comes under IC3. So here we need 2 ICs. So 7476 is the IC number. We need 2 ICs for this to design mod 5 synchronous up counter. I will take up the first flip-flop, that is flip-flop 1. So now I will do the connection for flip-flop 1. So for the flip-flop 1, there are 3 synchronous inputs. One is a clock, another one is a clock, another one is JA, and the third input for the flip-flop 1 is KA. And we have 2 asynchronous input, that is preset and clear. So for the first flip-flop, preset is preset 1, PR1, and the clear is clear 1 for the first flip-flop. And we have 2 outputs for this. One is QA, another one is QA bar. Like that, for the second flip-flop, we have 3 synchronous inputs. One is clock 2, another one is JB, and the second input is KB. And we have 2 asynchronous inputs, that is clear 2, as well as we have PR, that is a preset 2 and clear 2. So these are the asynchronous inputs. And we have 2 outputs. One is QB, another one is QB bar. Coming to the third flip-flop will comes under IC2, because in a single IC we can construct or we can consider only 2 flip-flop. For the mod 5 synchronous up counter, we need 3 flip-flop. So the third flip-flop will be considered in the second IC. So even the second IC is 7476. The second IC is 7476, which we are using in this experiment. So here we have a flip-flop 3, that is JK flip-flop 3. For this flip-flop, again we have 3 synchronous inputs. One is clock 3, another one is JC, and the third input is KC. And we have 2 asynchronous input, that is PR3, which is nothing but a preset 3, another one is a clear 3. These are the 2 asynchronous inputs. Coming to the outputs, we have 2 outputs. One is QC, another one is QC bar. Okay, so now I will construct the first flip-flop. So for this IC, now I will take one patch cord and I will do the VCC and ground connection. Here 5th pin is connected to plus VCC, 13th pin is connected to ground. So I will take one patch cord. So the 5th pin is connected to plus VCC and 13th pin. So here in this IC there are 16 pins, 8 pins on each side, which means that I need to consider 8 pins on the left side, and from the bottom right corner, so it starts from, the pin number starts from 9, 10, 11, 12, 13. So 13 pin is connected to ground. Okay, next coming to the flip-flop 1. The clock 1 is connected to first pin, which means that I need to take a patch cord. One end of the patch cord is connected to the first pin of IC1, another end is connected to the monopulse clock. So I will take up the patch cord here. One end of the patch cord is connected to the first pin, another end is connected to the monopulse clock. Next, after connecting the clock, we have a preset 1 and clear 1. So preset 1 is from the second pin of IC1, clear 1 is from the third pin of IC1. So both preset as well as a clear should be connected to plus VCC to activate flip-flop 1. Now I will take one patch cord. One end is connected to the second pin, another end is connected to the plus VCC. Basically this preset is connected to activate the flip-flop. Next, clear is from the third pin. One end of the patch cord is connected to the third pin, another end is connected to the plus VCC of that respective IC. I have completed a preset and a clear connection. So these are the two asynchronous inputs. Coming to the synchronous inputs, we have JA. So JA is from the fourth pin, and from the K-map simplification, we got JA is equal to QC bar. So here you can see QC bar is in the second IC of 14th pin. So 14th pin belongs to the QC bar, which means that what I need to do is I will take one patch cord. One end is connected to JA, that is the fourth pin of IC1. Another end is connected to the 14th pin of IC2. See here, I will do this connection. One end is connected to the fourth pin of IC1, which is nothing but JA. Another end is connected to the 14th pin of IC2, which is QC bar. Again in IC2 there are 16 pins, 8 pins on each side. So this is 1, 2, 3, 4, 5, 6, 7 and 8. And from the bottom right corner, the pin number starts with 9, 10, 11, 12, 13, 14. So 14th pin is QC bar. So now we have another input, that is KA. From the K-map simplification, we have simplified KA is equal to 1. So if we get 1, that should be connected to respective IC's VCC. So KA pin number is 16th pin. So the first IC 16th pin, I will connect the one end of the patch cord to the 16th pin of first IC, another end is connected to the plus VCC because we got KA is equal to 1. Next, we have done the connection for all the inputs of the flip-flop 1. Now we are left out with the output. So the output is from the 15th pin, that is QA. Okay, now what I will do is I will take one patch cord. One end is connected to the 15th pin of IC1, another end is connected to the QA. QA is nothing but the output. See here. So one end is connected to the 15th pin. So here in the left hand side of this IC we have 8 pins. From the bottom right corner on the right hand side, pin number starts from the bottom. So it starts from 9, 10, 11, 12, 13, 14 and 15. I will connect one end of the patch cord to the 15th pin. Another end I will connect that to the output 1. See here in this logic outputs, I will read the outputs from right to left so that the first output will be QA. So usually we need to read the output from right to left. So this is the first output. So I am connecting another end of the patch cord to the third pin. Now we are done with the connection of flip-flop 1. Moving on to the connection of flip-flop 2. So here flip-flop 2 is in the same IC, that is IC1. The 6th pin is connected to the monopulse clock 2. See here, this is the 6th pin. 1, 2, 3, 4, 5 and 6. One end of the patch cord I will connect that to the 6th pin. Another end I will connect that to the monopulse clock. Next we have preset and clear, which are the asynchronous inputs. So preset is from the 7th pin, clear is from the 8th pin. Both these should be connected to the plus VCC. See here, one end of the patch cord is connected to the 7th pin, that is a preset. Another end is connected to plus VCC. I will take another patch cord. So one end is connected to the 8th pin. So I am doing the clear connection now. The other end is again connected to plus VCC. So if I connect a preset and clear to the plus VCC, then that flip-flop will be activated. So from the IC diagram, we have the JB input. So JB is input the JB belongs to the 9th pin, which means that from the K-map simplification we got JB is equal to QA, which means that what I need to do is I will take one end of the patch, I will take one patch cord. One end of the patch cord is connected to the 9th pin of IC1, another end is connected to QA. Here QA is from the 15th pin, another end of the patch cord is connected to 15th pin. So one end of the patch cord is connected to 9th pin. So on the left hand side we have 8 pins. From the bottom right corner it is 9th pin. One end of the patch cord is connected to 9th pin, another end is connected to QA. QA is nothing but the 15th pin. QA is nothing but the 15th pin. Next we have KB. KB is from the 12th pin, and from the K-map simplification we got KB is equal to QA. Now what I will do is I will take one patch cord. One end of the patch cord is connected to the 12th pin, another end of that patch cord is connected to QA. QA is nothing but the 15th pin of the same IC, which means that I will take one patch cord here. One end is connected to 12th pin, so this is 8, this is 9, 10, 11 and 12. Another end is connected to QA, so QA is nothing but the 15th pin. Another end is connected to the 15th pin like this. Next we have the output from this flip-flop 2, that is from the 11th pin. So 11th pin, one end of the patch cord should be connected to the 11th pin of IC1, another end should be connected to QB, that is the second output. So I will take one patch cord here. One end is connected to the 11th pin. So here we have 8th pin, then this is 9th, 10th and 11th. One end of the patch cord is connected to the 11th pin. Another end is connected to the second output, that is QB. Here I am reading the output from right to left. And we are done with the connection of flip-flop 1 as well as we are done with the connection of flip-flop 2. Moving on to the third flip-flop. Third flip-flop is from the IC2, from the second IC, that is second 7476 IC. So here we need to do the connection. So coming to the third flip-flop, again we have three synchronous inputs, that is clock 3, JC and KC, and two asynchronous inputs we have here. One is preset 3, another one is clear 3. And we have one output, that is QC. Actually we have two outputs, one is QC and Q bar. We will consider only one output here, that is QC. Now I will take up the first connection, which means that I will do the clock connection here. The first pin, IC2 of 7476, first pin should be connected to monopulse clock. What I will do is I will take one patch cord. One end of the patch cord is connected to the first pin. Another end is connected to the monopulse clock. Next we have a preset and a clear connection. So preset is from the second pin and clear is from the third pin. So both preset as well as a clear should be connected to the plus VCC of this respective IC. So what I will do is, now I will do the preset connection. One end of the patch cord is connected to the second pin. Another end is connected to plus VCC. Next I will do the clear connection. One end of the patch cord is connected to the third pin. Another end is connected to the plus VCC. Next we have JC. From the K-map simplification we got JC is equal to QA into QB, which means that there is an AND operation between the two outputs QA and QB. If we have AND operation, then we need to use AND gate, that is 7408. Here in this experiment I am using the third IC, that is 7408. So it is an AND gate IC. The output of that AND gate IC is QA into QB. So that should be connected to the fourth pin. Now what I will do is I will do the AND gate connection. The inputs to the AND gate is from one input is from QA, another input is from QB, and output of that AND gate is QA into QB. That output should be connected to JC. Now what I will do is I will take patch cord. One end of the patch cord is connected to QA. Another end is connected to the first pin of 7408. I will take another patch cord. One end is connected to QB, another end is connected to the second pin of 7408. Then output is from the third pin of 7408. So I will take one patch cord. One end is connected to the third pin of 7408. Another end should be connected to JC. According to this IC diagram, JC is connected to the fourth pin of IC2. So another end should be connected to the fourth pin of IC2. Next, we have another input, that is KC. From the K-map simplification, we got KC is equal to 1. If KC is equal to 1, that need to be connected to plus VCC. KC is from the 16th pin. So now what I will do is, I will take one patch cord. So one end is connected to the 16th pin of IC2. So in the second IC base, so we have 8 pins on the left hand side, and coming to the bottom right, the pin number starts from 9, 10, 11, 12, 13, 14, 15 and 16. One end is connected to the 16th pin, another end is connected to plus VCC because KC is equal to 1. Next, we have output from the flip-flop 3. That output is called as QC. So QC belongs to the 15th pin. Now what I will do is, I will take one patch cord. One end of the patch cord is connected to the 15th pin of second IC. Another end is connected to the QC, that is the third output. See here, I will take one end of the patch cord. So I will connect this to the 15th pin. So in the second IC base, so on the left hand side we have 8 pins. Coming to the bottom right, this is 9, 10. Next we have 11, 12, 13, 14 and 15. I will connect one end of the patch cord to the 15th pin. Another end is connected to the QC, which is nothing but the third output. Here I am reading the output from right to left. I am not reading the output from left to right. So that's why from the right it is QA, next is QB and the third output is QC. And see here, the fifth pin should be connected to VCC. In the second IC, the fifth pin should be connected to VCC, 13th pin should be connected to ground. I will do this connection now. I will take one patch cord. One end of the patch cord is connected to fifth pin and another end is connected to plus VCC. Next, I will take another patch cord. So one end is connected to the 13th pin. So here in the second IC base we have 8 pins on the left hand. We have 8 pins on the left hand side, and from the bottom right corner we have, this is 9th pin, 10th, 11th, 12th and this is 13th pin. So one end of the patch cord is connected to 13th pin, another end is connected to ground. So we are done with the connection of both the ICs, that is JK flip-flop 7476 is the IC number of JK flip-flop. Next, as we have used AND gate, so for the to make the connection QA into QB in AND gate, I am using IC 7408. 7408 is the IC which need to be used for AND gate. In that AND gate, the 7th pin should be connected to ground. So what I will do is, I will take one end of the patch, I will connect one end of the patch cord to the 7th pin, another end I will connect that to the ground. Next, I will take another patch cord to make the VCC connection. So in 7408, 14th pin should be connected to plus VCC of that particular IC base. Now we are done with the connection. Now we need to verify the output. Now we need to verify the circuit by considering the output. Now we need to see the output. Now what I will do is, after doing this connection, switch on the trainer kit. I will switch on the trainer kit. Next, in mod-5 synchronous up counter, we usually get the outputs for decimal values from 0 to 4. We will get the outputs for the decimal values from 0 to 4 in mod-5 synchronous up counter. So if we have designed the circuit for mod-6 synchronous up counter, then we would have get the outputs from 0 to 5. So in this case, here what I have done is I have designed the circuit for mod-5 synchronous up counter. I should get the outputs from 0 to 4. So now see here, this is the first output, that is we have 3 zeros. So we need to see the outputs from right to left. So the binary representation for 0th decimal value is 000, and here we get the output, we have 000, which means that no light gets emits from these LEDs. So we don't have light which emits from the QA, and also we don't have a light which gets emits from the QB as well as from the QC. This is the first output. Now what I will do is I will press the monopulse clock. When I press the monopulse clock once, I got the output as 001. QA is, we have LED light, the LED light which emits from the LED light which is emitting from QA results 1, results the value 1, which means that QA is equal to 1, QB is equal to 0, QC is equal to 0. So the binary representation for the 1 decimal value is 001. Next, again I will press the monopulse clock. If I press the monopulse clock, QB is activated, and that should be read, the value of QB should be read as 1, and the binary representation is 010. For 2 decimal value, the binary representation is 010. Next, again I will press the monopulse clock. Next, I got the output as 011, which means that QA is activated, QB is activated, and QC is not activated, and the binary representation for 3rd decimal value is 011. Next, the last output, when I press the monopulse clock again, I will get the last output, that is 100. Here QC will be enabled, QB and QA will be disabled, which means that I should read the output as 100, and the binary representation for the 4 is 100. So in mod-5 synchronous up counter, we will get the output from 0 to 4. Up to 4 we will get the output. Again I will press the monopulse clock, it starts from 0. If I press the monopulse clock again, I will get the output as 001 like this. Next I should get 010. After that I should get 011. After that mod 4, the decimal value 4 is represented as 100 in binary, and I got the same output 100. Next again if I press the monopulse clock, again it starts from 0. If I press the monopulse clock again, then I get 001. If I press the monopulse clock again, I get 010. Next I get 011. Next I get 100. Again it starts from 0. Again the output starts from 0. So in mod-5 synchronous up counter, usually the flip flop, that is JK flip flop, counts the value from 0 to 4.